In the previous videos, we talked about some of the features on the task level, right? So we did some demos and look at some of the features. So now we reach to the level on the program and routines. In this particular video, we can look at above the feature called the fault routine, right? So same as before, we can first look at the menu from Rockwell. So I will post the link under the description, so you can look at those by yourself if you want to get into more details. So first, so let's see here. So there's sometimes there are faults involved with your program, right? So if there's something didn't set up correctly, it could cause a fault, right? There are major faults and minor faults. For the major fault, that will stop the execution, and also your controller will go into the faulted mode. So basically, your system crash, right? So you won't have any your logic being executed in your program, right? So that might not be the situation you want, right? Depend on the application you want, maybe to do automatic recovery, right? You don't want to shut down the system, then the controller switch into the faulted mode. So basically everything shut down, right? And if you want to avoid that, you can do it. So you can provide the handler to process the fault, and then you don't want the system shut down, then you can do some recovery based on your program, right? So yeah, you can see here it has the fault recovery option for you. All right, and let's look at the example, right? So there's a example on here. So on the example one, all right. So let's look at here. It has a JSR to jump to a subroutine. So this is a setup with a parameters. If you don't understand this, you can look at the next video. So I'm going to talk about the parameters. So basically on this example, if you read the description on here. So when your logic call the subroutine on here, then also pass a parameter. So with the parameter, you have a array. So with the array, you have the indirect index, but the number you pass in is a they create the name even that as a bad index. So that means it didn't set up correctly. So that will cause trouble, right? So when your logic running on this instruction, basically it has a fault, and then your program stop, right? So what you want to do the recovery is that because you don't know what time when that's going to happen, right? So you provide a recovery process. So whenever this situation happen, and then the program will not stop. You basically automatically recover from that and continue to move on. So your program don't stop. So this is the idea for the fault recovery, right? So I can use a example to demonstrate the process, all right? So, all right. So first, let's look at, let me see here, if maybe we can make the, let's see here, all right? So I just need to adjust the window so you can see better on the controller organizer. All right, so hopefully let me make smaller. Hopefully you can see better on the Studio 5000. So that's what I mean on here. With this example, underneath the task, which is continuous, we have a program, right? So before, if you remember, when we set up the program and routine, we need to be careful with that. One of the subroutines has to be in the main. You see the difference on the icon, right, between these two, right? So remember that whenever you want to add a new routine, so if you look at this window on here, right? So of course, because I'm online, right? So you can see here on the assignment, right? So uh, because it's online, I don't have. Let me try. Let me try if I switch to program mode, right? Because if I need to download again, that's gonna take a very long time, right? So that's one. Yeah. So yeah, it's good. So you can see here, whenever you create a routine, so one of the options is called assignment, right? So if you click on the pull down, you can see on here, the option is a fault, right? You can set up a fault on the new routine. So if you create a new one. So before, if you don't have the main routine, let's do it. Let's if I want to do it properly. So let me just go into the property on here, configuration. Remember before, I sometimes people made a mistake on this, right? So right now you don't have a main, right? So if you create a new one, so for example, if you create a new routine from the beginning, then in addition to set up the name, all right, so over here, you can see here on the assignment, you have two options, right? One of them is the main, the other one is a fault, right? So like currently, I don't have any the main routine set up as a in their configuration. So that's why I have both options, right? So the main routine is kind of like mandatory, right? Because if you don't set up the main routine, none of your logic will be run because main routine is the first one being called. So that's why it has a icon number one on the picture. So if you don't have a main, then nothing gonna run, right? So that's kind of like what I mean is required, like mandatory. But the fault is optional. You don't have to have a for routine to set up in order to run your logic. You can leave it to none. It's okay. But if you want to avoid being shut down in your system, then you have to set up that, right? So this is one way when you create a new routine. The other way is that you can right-click the program name, then go into properties. And within the property window, there's a configuration tab, right? So then you can see here, right? So you again, you have a main and a fault. So I want to set up a main. So that's where I want to set up. The fault currently is none. Like I said, I don't have to set up in order to run, right? So I can accept that at the beginning of here in order to see the fault. All right. So right now I have a main. Main routine is this. There's only one run in it, and basically I want to operate on the array, right? So I'm change back to run mode, and then let's look at the tag. So I have a array created, right? So there's three elements. So notice on here, inside the square bracket, it's called the index, right? So that indicate to point to different elements within the array. So because you create array with the size of 3, so the number within the square bracket can only change from 0 to 2 because you only have 3 elements in that, right? So that's basically it's the size of the limit of your array. But within the program, right, you can see here, Within the square bracket, you can use a tag to represent that. So in this way, you can change the value of the tag. That's what we call the indirect index, right? So that's different topic. But over here, I just want to illustrate with this setup, you better to set up a logic condition to guard against the size, right? Like we said, in this particular array, you only have 3 elements. So it's better to have the index to check the that before, right? So I'm going to show that, right? What I mean is that you should have a instruction, make sure the index value is greater and equal to 0. Then also you want to have the index less than 3, because you look at that, it can only change from the value from 0, 1, 2, right? So I just use 3 elements, a small one to illustrate that. So you need to make sure the index is with, or you can use a LIM limit instruction to make sure the value before you do the movement on the move instruction, right? So, but in order to illustrate the fault condition, I remove this. So in this way, I can create a fault condition on purpose, right? So then you can see the situation we are talking about. So like right now, you can see the index is 0. So you basically move value 1 to the first element. And if you change the index value from 0 to 1, then it's okay. The program is running. Then if you look at your tag value, right? So let's look at here. So you can see the first element with the index of 0 and 1, right? The 2 elements, they are both changed to value 1 because the logic on here, right? You move 1 into there. So now if you change to 2, it should be all right within the boundary, right? And then if you look at here, for sure, all the 3 elements are being assigned as value of 1, right? So it's normal way to run the program. But if you have somehow the value of index changed to 3, so now it will cause the problem, because it doesn't have the elements with index of 3. So once I enter here, so the PLC will continue to move 1 into the index of 3. So that will cause the controller to fault. And then you can see here, right now it's in the remote run with a green indicator. And then once you go into the fault, you see a red, and also it shows faulted, right? I'm going to press the enter key. Yeah, you can see here, and also it has a red flash, right? Controller fault and faulted, and then that turns to red. So you understand this is what caused the problem. And then whenever a similar situation like this happen, your program just stopped, right? So nothing gonna run. And if you click on here, you have an option called go to faults. That will give you more indication on here. So you can see there's a message, right? The recent fault, and that's the type of 4 and code of 20, and also some of the message, right? Detailed information and also the location. So I'm going to cut this message because we need to use this later on, right? So I'm gonna to cut this message, so then we can look at it later. All right. So if you run into this situation, right, you want to recover manually, right? So you don't have a program to do it automatically. You can do it manually, right? So over here there's a button, right? So you can click the clear faults. Once you click that message gone, then you can OK, back into there. So now you can see the controller goes back to the program mode, right? It won't go back to the run mode because if you run the logic again, it's gonna fault again, right? Let's try it, right? So that's why the controller is being put back into the program mode, right? It asks you to fix the problem, but if you don't do it and go back to the run mode again, then you're gonna fall again because the condition is still there, right? The index is still 3. So you can see it asks you, right? So if you go back, for sure, you can see it goes back to the fall again, right? So this time goes to the fault, and then you can directly clear the fault, right? So you can see here, so we already know what's caused that, goes back to program, and then if you change back to value 1, and then now if you go back to run, it's good, right? You can see the green bar highlight on here, so that means your program is running again. All right, so this is how do you process this from the manual way, right? But if you want to do it automatically, you have to create a routine. So over here, I already create that. So again, same thing. If you start from beginning, create a new, right? And then you can, if you're in the program mode or offline, this part will become solid. You would be able to click on the pull down to choose the fault. So that's how you create, right? Create brand new. But now I already have this routine created in order to make it shorter, right? So what you need to do is do the second way with the property window on here. So with the property window open, you can go to the configuration, and then currently there's a none option with the fault. Now you can choose this subroutine. All right, so now click OK, and then notice the icon is changed. All right, so I get this subroutine directly from the menu, right? Then by the link, you can look at it by yourself. So I don't want to switch back to the PDF again. In this way, we can carry on and make this video short. So within the menu, it suggests you to create a UDT. So if you don't know UDT, and I will put a reference link in the description, right? So basically, like what I just showed you, remember that we have a fault before, right? So that's the message I cut off from there, right? So it has a lot of information. It gives you the time, also detailed message, and also which task, which program, which routine, even which run, right? So that's the information provided by the PLC controller. So then you need to access those information in order to clear the file, right? So obviously that involves a lot of the information. Then how do we accept those information? On the menu, it asks you to create a UDT, right? So the UDT, the structure, it calls from the PLC provided to you is this. So I already create that in order to make the video short, right? So this UDT, you can give any name, right? I called that fault record. That's also the name suggested by the menu. So the PLC controller will provide you the information in this format. So first, the time, right? Use 2 double integer to include the information on the clock. And then the most important one is what we want to check with what type of the fault is that. And then different fault has different code, right? So on that, Allen Bradley, I think they have a file Excel file to give you all the information. Again, I will have the link post within the description. And then other information, like I said, right? So the location and other things, they even gave you a array, right? The 8-element array. So that's all the detailed information. So that in order to accept those information from the controller, you have to have the same structure. So that's why UDT become really necessary, right? So you have to create this UDT with this structure. And then within the tag, you can see here, I create a tag name called major fault with the data type of called the one I just created, the file record, right? So if you open here, so it has all the tags members within there. So in this way, you can pull all the information from the system into your program. Then how do you get there, right? So again, those are details from the manual, right? So I will post the link. So now I just need to show you the result, right? So within this subroutine, we first use a instruction called the GSV. So that's stands for get system variables, right? So and uh, in pair with this GSV, there's another one. It's SSV. It's set system variable, right? So basically, this instruction, you can see we get from this program. That's the format they request, right? So the tag, right? So we create, I already show you on there. It's a UDT, right? So we pull the information from the system and copy that into this structure, right? And then after that, I make sure I'm handling the specific fault I'm going to do. So because you can see here, the fault type is 4, value of 4. The code is 20. So I set these two parameters just because of this. You can see here, right? You can see the type is 4, code is 20, right? So that's where I get this from. Again, if you are handling different fault, you may use different value, right? So that's why they gave you an Excel file. I'm going to post the link on here. So if those two conditions are true, so that means you are handling the index too large file with the array. So how do we clear the file? Very simple. You just need to use the CLR to clear the type and the code. Remember, when you clear this, you're only doing this in the UDT tag. You basically only change the copy you get from your PLC system, right? That's only a copy, right? And then the SSV will get this copy back into the system, right? So in this way, you basically clear the file, right? That won't cause the shutdown with your PLC controller, right? So now with this setup, let's try it again, all right? So same as before, if I change the value to value greater than 2, right? So now I gave to 5. So I can change to 3 if you remember before, right? Before the value of 3 caused the trouble, right? So let's look at if this will cause the shutdown again. It didn't, right? So you can see here, notice here, it has unknown, the question mark. So that means it didn't execute this instruction because the PLC controller ran into problem, the fault, and then that fault will automatically call the subroutine of this one because you already set up as the fault handler, right? And within the subroutine, let's look at here, right? So you can see I also add numbers on here. So that means you can see here it's still causing the problem, right? Your system still running this, right? So if I go back to the main and change this to 1, and then if you go into the index, you can see here it stopped running. So that means everything is good now, right? So you don't see the number change, right? So otherwise, that means that this routine is constantly being executed, right? So that's what you see before, right? And then you can also choose a different way to handle the fault, right? For example, I can just provide uh, a simple solution. Uh, I think I create a fault. Let me see here. I forgot the tag name. Oh, here. Yeah, index fault. Right. So in this way, if you're in this subroutine, this tag index fault will be energized. Right. So that's finalize this. And within the main, right? So you can have a condition against on here, index fault. If it's not fault, you're going to the move, right? So if there's a fault, this condition will cut it off, right? So then you won't go into the routine again, right? So again, it's only a very simple way, but you could have the instruction guard against the value. Let's just do the demo. I want to try that on here. So this time, if you change it to 3, right, it didn't fault, right? And also, if you look at on here, it didn't increase the value. So that means this routine is only being executed once. It energizes the output, and then within your main routine, because of this, you didn't want the program continue to run, right? In this way, you recovered from the fault, right? So this is just a simple demo with this fault routine, all right? So from the menu, it also provide other options. So over here, the index fault, the routine subroutine is one way to do it. And then if you look at the menu, it provides 2 other options. One is that the controller fault handler. The other one is called power up handler, right? You know what? In order to show everything, maybe I should show you from the menu now. Then that's the end from this video, right? So let me go back to the PDF, right? So if you keep reading from this menu, then there's one part, right? It tells you over here. So the location, right? So that's the way I just demonstrate, right? You use a routine within the program, right, to handle the fault. You could also have other 2 options. One is the uh, fault handler underneath the controller fault handler. Or you can even have a power up underneath the power up handler. On here, I can pull up the software. You can see here, that's what I mean on here. So if you go to the controller organizer, those are the 2 folders you can create on that, right? So you may see what's the difference, right? So what's the difference on here? If you look at on here, yeah, so you can see under this chart, depends on the type of a fault. you will have to use different folder, different location to handle that, right? So that's the one we did within the program. You create a subroutine called fault routine. Or if you have other type of problem, maybe more specific, more severe, you will have to do the different location on there. All right. So on top of that, let me just I think I have the file download, right? So this is the one I download from the Rockwell. So this is basically a Excel file, right? So if you go down here, no, on different sheet, yeah. So if you go down here, right, it has list all different kind of faults, right? Notice here the type and the code, they are different and they have all the details. All right, so I will post the link.